All right, so in 2.3, we are going to be solving compound inequalities. Now think about even just like in your language arts class, what does a compound word mean? Anybody remember what a compound word is? Nobody? A compound word? Wow, I got to talk to your language arts teachers. Well then, what's a compound word mean? Two words in one word, like somehow, right? Because some is a word and how is a word, so somehow is a compound word. So when we are looking at compound inequalities, we are looking at two inequalities at one time instead of just one like we did in 2.2. So filling in this vocab, a compound inequality is an inequality that's formed by joining two inequalities with the word and or the word or. So what we're going to look at first is these or inequalities. And or is going to mean that a solution is only going to make one of those two inequalities that we're looking at true. So the solution's only going to make one of the inequalities true. And when we graph these, we're going to graph the compound inequality on one graph, and what they will look like when we graph them, these graphs are going to graph apart. So I've given you an example. Here's a compound inequality joined by the word or. So we have x is less than or equal to -2 or x is greater than 3. And what you'll notice is when those solutions are graphed on the number line, those arrows are pointing in opposite directions. So they're graphing apart. And that will always happen with an or inequality. So if you go to graph an inequality that's connected with the word or, and those arrows aren't pointing in opposite directions, you'll know you've done something wrong. All right? Now, solving an or inequality is really easy because once again, all we said was it's just two inequalities that are joined with the word or. So in number 1, we have p plus 5 is greater than or equal to 10, or -2p minus 2 is greater than 8. So all we need to do is solve each of the two inequalities. Instead of looking at one at a time, we're looking at two. So in this first one, all I got to do to get p by itself is do what? Yep, minus the 5. So that leaves me with p is greater than or equal to 10 minus 5 is 5. Then I'm going to come over and I'll solve the second inequality. For the second inequality, all I have to do to get p by itself, or I have to do two things this time, but first, I'll remove this constant. So since this is a -2, I'm going to add the 2 so that I have -2p is greater than 10. And then my last step there to get p by itself is divide by that coefficient. So we'll divide by -2. What happens when we divide by -2? Very good. We change that inequality sign. And then 10 divided by -2 is -5. So now, when we write our solution needs to be written just like it was in this example. The solution always needs to be written in order from least to greatest. So when we write our solution, because -5 is the smaller number, we will write this as p is less than -5 or p is greater than or equal to +5. And then when we graph that, it will make sense because we'll have -5 on this side of the number line, and then I'm just going to put 0 and 5. Make it nice and easy. On -5, since this is just a less than sign, that circle is going to be open and will shade to the left. And then since this is a greater than or equal to on 5, we will close that circle and shade to the right. All right, let's practice one more or inequality because, again, it's just two inequalities that we have to solve individually. So 2x minus 1 is greater than or equal to 3 is our first inequality. So the first thing I'm going to do to get that x by itself is remove that constant. So we'll add 1. 2x is less than or equal to 3 plus 1 is 4. Oh, right here. Do you need to go to the bathroom? You can use those paper towels too if you need to, Chloe. And if you need to go to the bathroom, you can go to the bathroom. All right, and then all we need to do to get this x by itself is divide by this coefficient. So if I divide by 2, I get x is less than or equal to 2. Now I'm going to come over to my second inequality, which is 1/2 x plus 4 is greater than 7. So undoing that constant first, I'm going to subtract 4. I get 1/2 x is greater than 7 minus 4 is 3. Yeah. No, just go because just go ahead and go. All right, and then please don't get freaked out by this fraction. X is being multiplied by 1/2. So how do we undo multiplication? So we're going to divide by 1/2. Which means x is going to be greater than, everybody should know how to make that fraction in their calculator. So when we do 3 divided by the 1/2, we get 6. Very good. When we found the solutions this time, they're already in order from least to greatest. So when we write that solution, it will just be x is less than or equal to 2 or x is greater than 6. And so then again, when we do our graph, it will already be in order, like it will match our final answer. So on the 2, we've got a closed circle and it's shading to the left. And then on the 6, we have an open circle and it's shading to the right. Both of those were or inequalities, and both times those graphs graphed apart, just like the or inequalities should. All right, so that is or, which is easy. Now we're going to move into and, which is also easy. The and is going to mean that we are finding solutions that make both of the inequalities true. And so the graphs of these and inequalities are going to graph together. So in this example that I've given you, it says x is greater than or equal to -6. So you can see how that's graphed here. And it says and x is less than or equal to 1. So that graph is here. Well, this overlapping area are going to be the solutions that make both inequalities true. So those are solutions that we're showing on this graph, which is why we don't actually see the continuation of these arrows. We just see these endpoints because we're just showing the solutions that make both inequalities true. Does that make sense? Hopefully. Remember, we had these endpoints at -6 and at 1. So I'm putting these endpoints and then, okay, so now what you need to understand is that because the solutions to an and inequality fall between two endpoints, we're going to write them in a more condensed form. So instead of writing and inequalities with the word and, we are going to write it to where basically what we're going to do is we're going to take this one and we're going to flip it around. So if I turned this around so that this endpoint at -6 came first, this would be -6 is less than or equal to x. Right? I didn't change the sign. The sign was eating the x. I just turned it around, so the sign is still eating the x. So what I'm going to do instead of writing this x twice is I'm only going to write it once so that the condensed form would be -6 is less than or equal to x. But again, I'm not going to rewrite this x because I already have it there. Now I'm just going to include which is less than or equal to 1. So instead of writing the word and, I'm just putting my x in between what those endpoints are. In between, didn't mean to erase that. X is in between those 2 points. So I'm taking this first inequality and just turning it around and then combining them. If I could move this, it's basically like I'm just sitting it on top of this x. Okay? All right. Now, what this also means is that when we see these and inequalities from the beginning, we can solve them separately, like we did with the or. But also with these and inequalities, since they're written as a single inequality, we can solve by performing the inverse operation to each of the expressions on the outside of the inequality signs. So these 3 below show this and inequalities that are already written in this condensed form. Now, you don't have to write this down, but I just want to show you like what I mean so that you understand that this is still 2 different inequalities. This is one inequality. -2 is less than x plus 1. And this is the other inequality. X plus 1 is less than 4. So we could always split that up and solve them 2 separate times. Or we can take advantage of this condensed form and just take this little shortcut method. So instead of doing this, we're going to take advantage of this condensed form, and we're going to get this x in the middle so that our final answer looks like this, where our x is in the middle, by using those inverse operations. So what's in the middle with x? A plus 1. How do we undo plus 1? So I'm going to minus 1 to both endpoints. And now I don't have to split it into 2 separate inequalities and solve it. I can just use this and make sure I subtract 1 on each of those endpoints. So now my x is in between. I can do this math. -2 minus 1 is -3, and 4 minus 1 is 3. And now I have my answer in that condensed form because I was able to solve it using that condensed form instead of 2 separate inequalities and then having to put them back together. So now when I graph this, my inequality signs are both just less than, so they're not included. So I've got an open circle here, an open circle here, and they shade together. All right, we're going to do one more with me, and then you're going to try number 5 with your partner. So again, number 4, we've got 3 is less than or equal to 5x minus 2, which is less than or equal to 13. Since it's already written in this condensed form, let's take advantage of that and solve it quicker instead of having to do 2 separate inequalities. So just like every single time, if there's a constant, we're undoing this constant first and then the coefficient. So we'll undo this minus 2 by adding 2. But we need to make sure we do it on both endpoints. So that now in the middle, I just have my 5x. Bring down my signs. I can combine the like terms on these ends. So 3 plus 2 is 5, and 13 plus 2 is 15. Then all I got to do to get x in the middle by itself is divide by 5, which means x is going to be in between. 5 divided by 5 is 1, and 15 divided by 5 is 3. So when I go to make my graph, on 1 and on 3, I'm going to have closed circles. And I'm going to shade together because x is in between those numbers. All right, you and your partner are trying number 5. Negative 2 is less than 2x minus 12, which is less than or equal to 4. I'm going to give you guys about 2 minutes. Not until we're done with notes. We should have gotten that x is going to be in between 5 and 8. So most of us did all the math correct, which is amazing. Some of us, the mistake I saw a couple times was that we weren't paying attention that the signs didn't match. So this dot should have been open on 5 but closed on 8. All right? How do we feel about and compound inequalities? Good? All right, our last 2, as always, the real world stuff. Number 6 says, the expression 45h plus 225 represents the total cost in dollars of renting a large party tent from a local rental store for H hours. Jamal's parents are willing to spend between $500 and $750 for the tent. Write and solve an inequality to find the number of hours that Jamal can rent the tent. So why is this one already kind of easier? Why? Yeah, they already gave us the expression, right? They already gave us 45h plus 225. So what we're going to do is we're going to set up how we would find what's the least amount of hours, what's the most amount of hours. So this 45h plus 225 can be greater than or equal to, what's the least that they want to spend? 500. But this 45h plus 225 has to be less than or equal to, what's the max they're willing to spend? 750. So we've written this as 2 separate inequalities, which is fine, but we could have saved some time and wrote it as 1 because this expression is exactly the same for both. So we could have written this more like an and compound inequality where we would have put this in the middle, and instead of rewriting it twice, we would have written it once and then flipped around. You know how we talk about turning around the inequality sign? Because this inequality sign needs to be eating the 45h. Why'd y'all let me forget that h 2 times? Nobody called me out on that. What the heck? Instead of writing that twice, we'll just write it in the middle. 45H plus 225. Now remember, that 500, that's the least amount, so that's the minimum. So we're going to write that first, and the gator mouth is eating the expression. So the gator mouth is eating the expression, and we got 500. And then we'll just put this endpoint down here. So less than or equal to 750. So the number of hours is going to be in the middle of the minimum and the maximum. And now we use all of our knowledge of solving inequalities, and we subtract that 225 from both endpoints. So that I have 45H in the middle. 500 minus 225. Is what? 275, and then 750 minus the 225. Very good, 525. Which means now all we have to do is divide by the 45. And we are going to get run on decimals, but you got to put it in real life context. So when I do 275 divided by 45, what's the minimum number of hours that he can rent that tent? 6. Very good, because you get 6.111199, whatever it is, 6.11111111. Okay? Then when I divide the 525 divided by 45, what's the maximum number of hours he can rent the tent? 11. Very good. So the number of hours that Jamal can rent that tent is going to be between 6 and 11 hours. All right, you guys have done great. We got the last one, and I'll just let us write it instead of writing and solving it. Karen earns a base salary of $3,500. I'm going to highlight that because it's probably important. Plus $200 commission for each sale made. She wants to earn at least $4,500, and the company will only pay at most $5,300 each month. Write and solve an inequality Karen could use to find the range of sales. So that's going to be her X, because that's what we're trying to find. The range of sales she needs to make to reach her desired earnings. Once again, this is a compound inequality where she wants to make between two endpoints. At least $4,300, but at most, at least $4,500, but at most $5,300. And that expression is going to be the same. So instead of writing the same expression twice, we're going to write it just like we did this one, putting those minimum and the maximum values on as our endpoints. So what's the minimum value that she wants to make each month? $4,500. So we're going to put that on one end. And this is the least she wants to make. So this $4,500 is going to be less than, because that's the least she wants to make. Now we need to write something to represent how much money she's making. So if she makes $3,500 plus $200 per sale, how would we write that? Prem? Very good. 3,500 plus 200x, because it's 200 per sale, and we're trying to figure out the number of sales. So we've got 3,500 plus 200x, and now this, though, has to be less than or equal to the max that the company's going to pay her, which is, very good, So we start with that minimum, which is always going to be less than we want to make, but what we want to make is going to be less than whatever our cap is. Okay? So notice on all of these compound inequality questions, the gator mouths are always opening in the same direction on these and compound inequalities. That's not like just a coincidence. That's what it's going to be like. Okay? All right.